So, welcome back again on 100 Days DSA Mastery course. And today, what we're going to do is learn the quicksort algorithm. This is day 5, and this is going to be an interesting algorithm which we are going to study. So, let's just go on to the definitions as we always do, the theoreticals and then practicals. So, first we'll see the definition, then we'll move on to the process, like the step by step. How do we get started and what do we do next and next and next? And then we'll look at some advantages and disadvantages of using this particular algorithm, and then we'll do this practically. That's where you'll start to understand like why do we actually use this algorithm and where do we actually use this. So let's just look at the definition of it real quick. All right, so quicksort is a highly effective and widely used sorting algorithm that uses the divide and conquer strategy. So what it basically does is just it creates the partition of the arrays into subarrays, and then it will sort the subarrays recursively, like over and over until they are sorted. Until all the subarrays are sorted, it will do the recursions, and once all the subarrays are sorted, it will merge all of them, and then you have the output. You have the perfect output of a perfect sorted list. That's how it works. It's a really efficient and widely used sorting algorithm. It is renowned for its performance and versatility. Often begin go-to sorting method in many library systems. So let's just look at the steps of this algorithm to understand it pretty much better. All right, step 1, choose a pivot. Select an element from the array as the pivot. Common choices are the first element or maybe the last element, or if you want, then you can even choose any random elements. So what you basically does is just create a just select any kind of element as your key element or pivot element, which will be used further for the comparisons to sort the data, because that's what we do. We take a key element or take a pivot element or take any random elements using like the for loop or something like that, and then what do we do is just swap elements one by one. That's how we do like the sorting stuff. All right, so what do we do first is choose a pivot element. Then there is the partition of the array. So rearrange the elements so that the element less than the pivots are on the left side and greater than are on the right side. So that's why we choose the pivot. So pivot is basically will be on maybe on the middle point. Let's just say that it's a middle point. Assume that it's a middle point, and then if the elements are smaller than the chosen element, the key element, then they are placed on the left side, and if they are bigger, then placed on the right side. And that's how the sorting will be work. All right, the third step is recursively sort subarrays, and you have to just apply the same process to left and right subarrays until the entire array is perfectly sorted. So let's just take a quick look at the advantages and disadvantages of it. So what are the advantages of using quicksort algorithm? First is efficiency, average time complexity. Quicksort has really an average time complexity of O(n) log n, which makes it faster than other sorting algorithms like bubble sort or selection sort. It is really faster than both of those algorithms. Then it has the in-place sorting, which is minimal memory usage. Then what else do we have is versatility, means general purpose sorting. The quicksort can be used in many applications and libraries such as Python's built-in sorted due to its efficiency and adaptability. That's why we called it versatile. Performance on large data set. It helps you handle large data sets effectively, or let's just say efficiently, because quicksort is particularly effective for sorting large data sets due to average case performance and ability to handle data in various orders, like no matter what the order is, random order or a semi-ordered. So now let's just talk about the disadvantages of it. First one is worst case time complexity. If the pivot selection is poor, then it will cause you time, because if you always choose the smallest or always choose the largest element, then it just creates a time complexity, because it's harder now to compare because you have chosen the largest element. So the largest element will be always on the right side at the end, so every single element will be on the left side, so it makes it harder for sortings. Then what do you have is stability. not stable by default, because quicksort is not stable sort, meaning it does not have to have the preserved relative order of equal elements unless specifically implemented to do so. Then what else do we have is recursive nature. Stack Overflow. Due to its recursive nature, quicksort may use a Stack Overflow on system with limited stack space or very large datasets. Then the last one is pivot selection. Crucial for performance, the choice of pivot can significantly impact performance. A poor choice of pivot can lead to imbalanced partitions and degrade performance. All right. So the first thing that we do, as always, is just create a function which will be called as quick sort. So doing the practical actually gets you more understanding of the code rather than just understanding it theoretically. Like practicals are always on the top, like it levels out everything. So first, as we always do, is just check if the length of the array is greater than 1, is smaller than the 1. If it is not greater than 1 or equals to 1, then it will return the array. That's it, simple as that. You don't have any kinds. And if it is greater than 1, then we'll choose the pivot element as the middle element. We'll simply just take the middle element. You can choose any random elements, but we'll just take the middle by extension. So the first thing that we do is just take the, this is called as the pivot selection, where you choose the pivot as your middle element, and then you do the partitioning. Like you create 2 different subarrays, or let's just say 3 different subarrays: left subarray, middle subarray, and right subarray. The arrays that contains elements less than the pivot, then there is middle subarray which contains elements equal to the pivot, and then there is right subarray which contains elements greater than the pivot, right? So this is the easiest way to implement that. Like you can see that for x in array, if x is blah blah blah. Then we'll do the recursion. Recursively apply quicksort to left and right subarrays, right? And how do we do that? Is just return quicksort left plus middle plus quicksort right. That's it, simple as that. And here we're done with the entire function. Like that's it, this is all the function have got. Quicksort, and then we'll just say right. We're done. Now just create an array and implement the function, call the function. This is how we do stuff. Like we just concatenate the spotted subarrays and the middle subarray and the sorted subarray, and then we have the entire sorted subarray. That's it, simple as that. It's not really complex. Okay, let's just say quick sort array, run this program, say 5, run this, and we'll get our output in a matter of seconds. And you can see it's the perfect sorted array. So this is how you do the quick sort algorithm. So see you in the next one with a new algorithm. Till then, just go and download the code. It's in the description. And also keep on practicing the DSA. And if you find any kind of difficulties, just go and comment out it below, and I'll help you solve that problem.